Assalamu alaikum. Hi viewers. My goal, my purpose of these lectures is to help you in preparing F.Sc physics without any difficulty. You will observe that I make things and the lessons so easy in physics that most of you will feel like a prepared food and only to eat. Friends, the remaining four conceptual questions here. Question number 7 is will the energy stored in three capacitors be greater when they are connected in series or in parallel? So the answer is that the parallel combination of capacitors will store more energy, greater energy. So its reason here is that in parallel combination the total capacitance will be larger. Explanation. So for explanation, consider three capacitors here of capacitance is C1, C2 and C3 connected in series with a battery. The total or equivalent capacitance is determined by this relation 1 over Ce equals to 1 C1, 1 over C2 and 1 over C3. Now let all the three capacitances are equal and equals to C. Here we plug the values. 1 over Ce equals to 1 over C plus 1 over C plus 1 over C. We simplify and finally we get 1 over C equals to 3 over C. Now inverting both sides we get C equals to C by 3. Now we find the stored energy. Here we use the formula U equals to half CV square. In place of C we write CE. The value of CE you see here is C by 3, and we plug the value of C over here and rearranging 1 over 3 is taken out and half CV square is kept in the brackets. So this is the original value of the energy, and we put over here is U, so U dash becomes U by 3. Here we see that the energy is decreasing. Dividing means that the energy stored is decreasing. Now let us come to the case of the capacitors, where the capacitors are connected and parallel to a battery. So equivalent capacitance formula in this case is Ce equals to C1 plus C2 plus C3. Capacitances are equal. Put the values in this formula, we get C plus C plus C, and equivalent capacitance becomes equals to 3C. Now stored energy will be U equals to half CV square. C is replaced by C E, so CE value is 3C. Plug over here 3C. 3 is taken common out and rearrange 3 into half CV square. Half CV square is the original energy U. So here you see this U dash becomes equals to 3U. It means that the energy is multiplying. So for 3 capacitors the energy is 3U. For 4 capacitor energy will be 4U, and similarly if there are n capacitors in parallel the energy becomes n times of the original energy. Now from comparison of these two equations we see that here energy is decreasing, dividing, and here energy is increasing because it is multiplying. Now question number 8, can different equipotential lines cross each other? So answer here is that it is not possible. The reason is that when any two equipotential lines cross each other, it point So at a point there will be two values of electric potentials. Consider the figure in which equipotential surfaces around a charge are shown. So here the two equipotential surfaces 1 and 2 are intersecting and crossing each other. So the two here, the two equipotential surfaces are crossing each other at point P. So at point P, the potentials will be V1 equals to KQ by R1, and let it is equals to 20 volt. Now for the second equipotential surface, the equipotential will be the potential will be equals to KQ by R2, and let this value become equals to 15 volts. So for the first equipotential surface, the electric potential at each and every point is 20 volt, while for the second equipotential surface, the electric potential is 15 volts. So the point is single by two values of potential, so this is impossible. We placed a test charge at this point, so there will be two directions forces on the single charge. So single charge will move in one direction, and the same charge will be observed to move in the other direction. So this is not possible that one man and in two places. Now he is moving. If an electric charge is placed at this point of intersection of the two equipotential surfaces, so the test charge will move on the two paths simultaneously physically, and it is not possible. Other examples are the magnetic field lines or can also never cross each other. Similarly, gravitational field lines, these are also equipotential lines and they can also never cross each other. Therefore, if we placed a test magnet compass needle at that point of intersection, so compass needle, if the magnetic field lines crossed, so the compass needle will move simultaneously left and right too. So this is not possible. Conclusion is that the equipotential line never cross each. Now consider question number 9. Water has large dielectric constant but rarely used in capacitors. Why? So its answer is water is not used as dielectric in between plates of capacitor. Its reason is that ionization form, which is like a conductor, and capacitor cannot store energy. It flows the energy continuously and cannot be stored in between the plates. So explanation, consider equation for parallel plates of capacitor. C dash equals to A epsilon R epsilon naught by D, or we can write C dash equals to epsilon R into C. The medium effect here is that the capacitance will increase because it is multiplying the value of the permittivity is multiplying. Use water as a dielectric between plates of the capacitor. But if you used water between plates of a capacitor, energy stored will be equals to 0. Actually, during charging process, the water ions allow the current to flow between plates and no energy is stored. Let water is used as a dielectric between plates of the capacitor. The energy stored will be equals to 0. Actually, during the charging process, the water ions allow the current to flow continuously and no energy is stored. Likewise, example is that of metal. If metal is used between plates of a capacitor, is dielectric. So if metal is used as dielectric between plates of the capacitor, so metal is having free electrons for the flow of charges. So therefore, if charges come and want to store there on the plates of the capacitor, they cannot store because the conductor allows them to flow forward and no energy will be stored. Conclusion here is that water cannot be used as a dial. Question number 10. How can you increase capacitance of capacitor? So its answer is it. Yes, capacitance can be increased. Separation, permittivity, and area of each plate play the role. Here, for explanation, consider capacitance of pair of plate capacitor, which is equals to A E naught by D. Three factors affect capacitance of a capacitor. So, if area is increased of each plate, then capacitance will increase. Similarly, permittivity or medium, if greater permittivity value medium is placed between plates of a capacitor, so capacitance will increase. Similarly, if distance between plates of the capacitor is decreasing, then the capacitance will increase because these two are inversely proportional while these two are directly proportional. Thus, the three factors which can be used to increase or decrease capacitance on capacitor. These three factors are area of each plate, medium permittivity value, and the separation between the plates. So this was the last question, dear all viewers. Dear viewers, please subscribe and share for to help someone.